All right, so lecture 10, dynamic binding. What you'll see with dynamic binding is what we've been doing. So dynamic binding occurs at runtime, right? When you compile your program, the compiler doesn't know what type of object you're creating. It only determines that at runtime. For example, when we declare an athlete reference variable, then at runtime, we give the user the option to create a basketball player, tennis player, whatever it may be. So if we look back at our assignment 7, let's say we don't have this array. Let's say we just create one athlete. Athlete equals new athlete, right? We're not creating an array. And actually, we're not even creating that object yet. We just create athlete, right? No array. This would be a reference variable, right? Reference variable. I'm going to delete this right here. I'm going to delete this. So basically, all I'm doing is the user is going to have the option to create either a tennis player or a basketball player, right? And at runtime, this athlete object will become either a tennis player or a basketball player. But just looking at this code, athlete equals create athlete option. Just looking at this code at compile time, it won't know what type of athlete I'm creating, right? I could create a tennis player or a basketball player at runtime. So when I run it and the user types in a 0 or 1, it'll create either a tennis player or a basketball player. But at compile time, so once I hit save and I compile this, it won't know what type of object it is until I actually run it. That's called dynamic binding. It's dynamic. It depends on runtime behaviors. All right, does that make sense? Yay, nay?
Yeah, that makes sense.
All right. So again.
Yeah.
Yeah. All right. All right. At runtime, again, dynamic binding means that we'll determine what type of object it is at runtime, not when I'm writing the code and I compile it. All right. So for example, this user gets to decide what type of player it wants to create at runtime, and then this athlete object up here is created at runtime. All right, I declare it up here, just a general athlete. At runtime, it's going to be either a tennis player or a basketball player, depending. All right. So that's dynamic binding. The next thing is instance of. All right. So it's a Java keyword used to determine if an object is an instance of a particular class. And let's say, for example, we declare our athlete reference object. Then we use dynamic binding to create a basketball player. Right? So at runtime, the user decides, hey, I want to make a basketball player. Let's say I have another method that takes in that athlete. Whatever that athlete is, I can check for the type of player it is using instance of. So let's say I have another method down here, public static void display the type, athlete. Basically, all I want to do is display what type of athlete it is. Is it a basketball player or a tennis player? Okay. So I can use if athlete instance of, I gotta spell instance right, instance of basketball player system dot out dot print line basketball player. Else if athlete instance of tennis player system dot out dot print line tennis player. right? I can check and be mindful. This is the name of my class, basketball player, right? Capital B, capital P. Same with tennis player, capital T, capital P. So I can check if this athlete, which is just a general athlete class, I don't know what it is when I pass it to this method. I don't know if it's a basketball player. I don't know if it's a tennis player. I don't know if it's just an athlete. But I can check for that using instance of. All right. I can check. Is it instance of basketball player? Is it instance of tennis player? Those are things I can check for. Right. So when I run this, actually, let me call the method. Display the type, and I pass in this athlete. So what type of athlete? I'm going to make a tennis player. Serena. Something crazy. And you see now, I created the tennis player, right? So this was from my method, create athlete. It created the tennis player and it returned TP. I said athlete equal to that. Then I called display the type. It goes down to display the type. And it checks. If athlete instance of tennis player, it printed out tennis player. All right. And I could do this for all of them, you know, and then I would do system.out.println athlete.toString. I can do this for all of them, basketball player and tennis player. And this is really helpful if, say, for example, in your program, you know you're going to have an athlete, you know, a water polo player or whatever. Say, for example, I'm creating the Olympics whole roster. There are multiple types of athletes, right? But I need to create just a general registration form for all those athletes. So what I would do is create an athlete class with a whole bunch of different types that inherit from it. That way, anywhere in my program, I can check to see if it's a water polo player using instance of, right? And then obviously the water polo player would have different characteristics from a tennis player or a basketball player or a weightlifter or a track and field runner, right? Any of those different types of athletes have different characteristics, but they all are part of a general athlete class, all right? And that's really helpful in programming, and that's polymorphism, right? That's really helpful in programming because I can do things like this. I can just accept a general athlete, but inside my method, I can then, you know, go even deeper and be more specific with which type of athlete I want to use, okay? So it's really helpful when you're doing large programs and you don't necessarily know what specific type you're working with, type of, you know, a superclass, but you know the superclass. If you know the superclass, there are some common characteristics, and you can use polymorphism to accept those within different methods. All right. All right. I'm going to assume that makes sense. Lastly, we have the equals method. So if you remember in Java, when you create an object, it's actually a pointer or a reference to an object in memory, right? So for example, this athlete variable up here, it points to a spot in memory where all of this information is actually held. So with that being said, I can have multiple pointers to the same spot in memory. So I can do something like this, athlete, A2 equals athlete. I can do this. But in reality, A2 points to the same little block in memory that athlete does. They point to the same block in memory, right? And so what you can do is you can check if A2 dot equals athlete, right? That'll check to see, are they pointing to the same block in memory? If so, this if statement is true, right? If they are not pointing to the same block, so if I, instead of doing this, I did new athlete, right? That would make A2 its own unique block in memory. So these two would not equal each other. Okay? Does that make sense? If the pointers are the same,
Yes, sir.
yeah. If the pointers are the same, they would equal each other. If the pointers are different, they don't equal each other. The problem is, as programmers, we don't necessarily want to see if something equals itself based on the pointer. That's not really helpful to us. What if I want to determine equality based on the name, right? If the names are the same, then they're the same athlete, right? So if I create a LeBron James, if I create two separate athlete objects with the name LeBron James, I want to check if they're equal to each other based on the name, not the pointer. I don't really care about the pointer. I want to know, does this athlete equal this athlete based on their names, okay? If I want to do that, that is a unique equal behavior, right? That behavior is unique. It's not based on the built-in method, which uses the pointers. It's based on a method that I want to create. Are you writing on my screen? Michael, is that you?
Yeah, I did that on accident. My fault.
I didn't even know you could do that.
I didn't either. How do I erase it?
I have no idea.
There you go.
All right, so that's kind of weird. But basically, I want to look at it based on the name, right? That's a unique characteristic and behavior that I want. So for me personally, I want to determine equality based on if this player's name equals this player's name. That's my logic for equality. So if you want to do that, what you need to do is inside of your class that you want to compare, right? You need to override the equals method. At override public, I think it's int equals object O, I believe. All right, so it's Boolean. Public Boolean equals. So I can just say return, actually first, so something we need to do is something called an explicit cast, which basically converts this general object, which again, that is the biggest superclass. I need to convert that to an athlete. So athlete other equals, and how you do that is just put the type in parentheses and then whatever you're trying to convert. So I want to convert O to an athlete. So I put that in parentheses and O. Keep in mind, when I pass in this O, polymorphism, it must be an athlete, or this line would return an error. And we'll actually talk about explicit casting in more detail later on. But for
I thought you named the athlete A2.
You said what?
I thought you had named the other athlete A2.
That's in my main. Then this method, I just want to, it doesn't matter what I name it. I can name it other. It's just whatever I'm comparing this object to, all right? So when I create an object and I want to compare something else to it, I pass in that other athlete, whatever I want to name that. It's just another pointer to that athlete, all right? And then I could just return this dot name dot equals other dot get name. So basically what I'm doing is I'm returning, does the name of this athlete equal the name of the other athlete? Return that value. That's what I want my equals method for the whole object to return. based on the name, not based on pointers. This is based on, does this name equal the other athlete's name? All right. So A2 dot equals athlete. I'm going to set A2 dot name dot set name. I'm going to say LeBron James. And if A2 dot equals athlete, so I'm checking, does LeBron James dot equal our original athlete's name? If that's true, system dot out dot print line, they equal. All right. So now let's run this. The first one, yeah, it's not going to work. So let me just do LeBron. Let me do one name. And why are you doing this? Okay, that was weird. Player weight. I don't think the names are going to equal just because these lines are messed up for some reason. Hold on. All right, now it should work. Let's see. And it's saying they don't equal. So now this would be where we would debug it. So why are they not equaling each other? And then we would debug it, go from here. Actually, I want to go here. So 1. All right, so we're here. So our athlete, I create athlete. Our athlete is LeBron James or whatever. So the height is 6'8". Name is LeBron. Weight is 250. Assists, points, and rebounds. We create our athlete 2. We set the name. A2. Right here. Oh, I know why. I know why it doesn't work. So when I create this one, that's a basketball player. And this name, I put this equals method in the basketball player class. So I need to put this in the athlete class. Now it should work. What time is it? Mike, you messed up my computer. I can't see the time no more. All right, I got 3 minutes. All right. And 250. And again, it still doesn't work, so we would debug it and figure out why it does not work.
No, it said they equal.
Did it say it?
Yeah, it said it like in between the statements though.
Okay, let me put this above it then. Let me put this up here. All right, one more time. All right, so it does say they equal. And that's based on their names, right? If I just did this without this method, if I didn't override this equals method, these would be false, right? Because they don't point to the same athlete. But since I overrode the equals method in my athlete class and I made it based on the name, now they equal each other. And I could change this, I can check for if the name equals, if the points equals, if the rebounds, if the name, the height, I could check for all that stuff inside my equals method. It just depends on what you want to put as your logical operations to determine equality, all right? again, as a programmer, that's very powerful because you can kind of use your own unique behaviors and characteristics for how you want to determine if one object equals another. All right. So today we didn't get to array list, but we'll talk about that on Wednesday. It should be fairly quick since we did it in programming 1. The only difference again is I'll use it for an athlete. Then you can use objects inside an array list. You can sort it. Same with equals, sorting, you can do it based on your own unique characteristics as well. All right. So with that, I will see you on Wednesday. Hope you all have a good rest of your 2 days.
I have a